June 2025. Observations from the Atacama Large Millimeter Submillimeter Array reveal something unprecedented. A distant exoplanet designated LK447b, orbiting a red dwarf star 47 light-years away, shows signs of artificial thermal regulation. But when the infrared spectrograph detects layered atmospheric patterns that appear engineered rather than natural, the entire astronomical community takes notice. The planet's temperature fluctuations follow a mathematical progression. Its atmospheric composition shifts with calculated precision. Its orbital mechanics align with orbital engineering principles. Then comes the confirmation. Multiple research institutions verify a structured electromagnetic field encircling the planet and detect modulated laser pulses cutting through its upper atmosphere in patterns that suggest intentional communication. If this data is accurate, it could represent the first direct evidence of technological civilization beyond Earth. So what is LK447b? And why does its discovery have leading planetary scientists worldwide demanding immediate action? June 14th, 2025. Deep within the observational data streaming from the Atacama Array facility in Chile, a research team led by Dr. Marcus Thornton made a discovery that defied their initial explanations. The first millimeter wave scans of LK447b revealed atmospheric layers arranged in a structure unlike any natural planetary formation. Not random compositional gradients, not the chaotic mixing expected from planetary weather systems, but carefully organized bands, each distinct and stable, spanning the planet's entire circumference. The readings came through clean, with no equipment malfunction indicators or solar radiation interference. On the spectrum analysis plots, the pattern jumped out immediately. Precise chemical concentrations stacked in ascending order, each layer maintaining perfect vertical stability, all concentrated in what appeared to be an intentional atmospheric design. The research team, composed of specialists from 4 continents, cross-checked their instruments multiple times. The readings remained consistent, showing stratified atmospheric patterns at temperature gradients 10 times more stable than Earth's own atmosphere. The patterns were deliberate, unchanging, focused entirely on planetary maintenance. Staff communications erupted with urgent questions. Was this natural planetary evolution or something profoundly different? Comparative analysis began without delay. Archive data from the TESS satellite, collected over the previous 18 months, revealed that LK447b had maintained these atmospheric conditions with minimal deviation. The planet's thermal profile had remained suspiciously consistent, resisting the natural fluctuations that characterize all known worlds. No solar storms had disrupted the balance. No internal geological activity had altered the measurements. For the research team, it became clear this was far beyond routine planetary observation. The atmospheric control was coming from an engineered system, not from natural planetary processes. The planet maintained equilibrium with absolute precision.
spectroscopic examination teams coordinated by Dr. Sarah Chen across multiple observatories began their own intensive review. Their initial assessment focused on the thermodynamic impossibility. By every established model of planetary science, LK447b maintained internal heat distribution at a level requiring active technological intervention. The thermal balance sheets analyzed over months showed virtually no fluctuation, no seasonal variations, no day-night temperature swings, no evidence of the chaotic convection that typically characterizes planetary atmospheres. When compared to Earth, Venus, and Mars, LK447b's thermal signature appeared almost artificial, maintained by a system that actively compensated for any deviation. The high-resolution spectroscopy sought evidence of extreme geological activity, volcanic outgassing, core convection, thermal cycling, anything that might explain the readings through natural processes. Instead, the data revealed something far more intriguing. The planet was wrapped in what appeared to be a sophisticated orbital solar shade, a structure barely detectable but unmistakably present in the gravitational lensing patterns. Researchers noted that even from 47 light-years away, where electromagnetic interference from the parent star dominates and most planetary signals fade into background noise, LK447b's thermal signature remained crisp and organized. No geological mechanism or stellar heating model could account for such perfect equilibrium and such obvious artificial design. These contradictions presented the spectroscopic teams with an unprecedented puzzle. A planetary system too stable, too precisely controlled, and too mathematically elegant to fit any known natural formation. Every assumption about planetary evolution simply did not apply. For the scientific community, the implications became impossible to ignore. If the thermal control wasn't occurring naturally, then something or someone was maintaining it deliberately. Atmospheric composition analysts working with Dr. Chen's team began a meticulous examination of LK447b's chemical profile, searching for any evidence of technological processes operating within the planetary system. What emerged from their analysis was nothing short of revolutionary. Every 7 hours, precisely on schedule, the planet's upper atmosphere released a burst of electromagnetic energy coupled with a distinctive pattern of chemical emissions. The pulse was unmistakable, steady, almost rhythmic, with radiation peaks concentrated at specific frequencies and molecular signatures flooding outward in waves. No random chemical reaction, no chaotic atmospheric discharge. The pattern repeated with mechanical precision that suggested intention and design. Dr. Chen's team mapped the temporal intervals against the planet's rotation, orbital period, and stellar radiation cycles, desperately searching for any natural phenomenon that might explain the pattern. nothing aligned. The emissions didn't correlate with solar input variations, they didn't track with the planet's day-night cycle, they didn't respond to the stellar wind fluctuations. Instead, the signals emerged from deep within the planet's mantle, independent of any surface processes or external forcing.
To the atmospheric specialists, it appeared less like planetary weather and more like the operational heartbeat of an active technological infrastructure. The precision was simply too great to occur naturally. Radio astronomy facilities spanning from Australia to the European continent directed their sensitive receiver arrays toward LK447b, searching for any electromagnetic signals beyond the infrared and visible light spectrum. The Green Bank Observatory, led by Dr. James Patterson, began sifting through weeks of continuous monitoring data, isolating artificial signals from the background cosmic radiation and stellar noise. The team identified something that stood apart from all natural phenomena: a modulated laser beam, narrow and intensely focused, repeating every 7 hours with absolute precision. Fourier analysis of the signal confirmed the pattern: a distinct carrier frequency, digitally modulated, standing out sharply against the ambient radiation with a repetition too precise for any random cosmic event. Across multiple observation cycles, the signal remained stable, yet its frequency drifted in response to changes in stellar radiation pressure, matching variations tracked by space weather monitoring systems with extraordinary accuracy. Independent research groups at the European Southern Observatory and the Asian Pacific Radio Astronomy Consortium verified the signal, eliminating local interference and all terrestrial sources as explanations. The laser's persistence, its apparent response to environmental changes, and its replication across multiple independent observations from different hemispheres forced a revolutionary question into mainstream scientific discourse. Was this a natural phenomenon or deliberate communication from a technological civilization? Late June 2025, the mystery intensified dramatically. The Atacama Array captured a sudden surge in the planet's thermal output. LK447b's surface temperature increased by approximately 35% in less than 90 minutes. The TESS satellite, monitoring from space, confirmed the dramatic spike. Every major observatory on Earth trained on the target registered the same surge, not merely in visible light, but across the entire electromagnetic spectrum. For a brief critical period, the planet radiated energy as if some massive technological system had suddenly engaged at full operational capacity. Then, precisely as abruptly as it had begun, the thermal surge subsided, stabilizing at a new elevated baseline that persisted continuously. Scientific attention immediately shifted toward orbital mechanics. Dr. Elena Rousseau and her team at the International Astronomical Union calculated revised trajectory predictions for the LK447 system. The anticipated gravitational behavior derived from months of measurement data no longer matched observed reality. Instead of maintaining its current orbital position through standard gravitational interaction, the entire LK447 system displayed subtle but measurable changes in its motion through space. Rousseau's team engaged in intense debate regarding the mechanism. Was it radiation pressure, relativistic effects, measurement uncertainty, or something entirely outside conventional physics? The acceleration demonstrated none of the characteristics associated with any known natural process. For the first time, evidence suggested deliberate engineering, with both the thermal surge and the orbital adjustment appearing coordinated in the data records. The question now demanded immediate answers. What kind of planetary system adjusts its orbital parameters in response to internal events? And what purpose might such capability serve within a stellar system?
Late June 2025, the spectroscopic analysis team working under Dr. Robert Kasawa from the European Southern Observatory received the raw spectral data from LK447b and began their detailed chemical analysis. The anticipated signatures for water ice, carbon dioxide, and methane appeared as expected, but layered beneath them existed an entirely unexpected puzzle. Several distinctive absorption features refused to match any entries in the comprehensive catalog of known chemical compounds. The spectral reflectivity profile hinted strongly at metallic alloys and rare earth elements typically found only in advanced technological manufacturing on Earth. Embedded within the complex spectrum were signatures consistent with theoretical metamaterials, sophisticated lattice structures described extensively in physics literature, but never observed occurring naturally in any planetary atmosphere. Chemical analysis revealed evidence of isotopic ratios that could only occur through deliberate artificial processing, not through natural cosmic synthesis. For the assembled team, the evidence accumulated in one direction with increasing certainty. The planetary atmosphere composition didn't suggest random chemical accumulation, but rather indicated sophisticated technological intervention and engineered atmospheric management. By late June, access to the raw observational data began to tighten substantially. Internal communications from major space agencies referenced new protocols governing data distribution, citing planetary security and the need for controlled information release. The Committee for Extraterrestrial Contact Protocols, assembled from representatives of every major spacefaring nation, held emergency sessions to debate the appropriate response. After extensive discussion, the decision was made to transmit a carefully constructed signal toward LK447b. The message contained fundamental mathematical sequences, the periodic table of elements, and core physical constants, information that any technological civilization would immediately recognize as deliberately crafted communication. For 72 hours, Earth's telescopes and radio dishes waited for any response. Then, precisely on schedule, at the exact moment the signal would have reached the LK447 system, a narrow-band transmission arrived at Earth. The return signal arrived with stunning accuracy, its pattern mirroring the original transmission precisely. Structured elements appeared where expected, mathematical relationships aligned perfectly, and the entire sequence matched predictions to extraordinary precision. Government officials immediately secured the data, rerouting communications through classified channels and restricting access to highest-level scientific personnel. Outside the scientific community, speculation intensified dramatically. Inside government facilities, the atmosphere shifted fundamentally from pure scientific curiosity to something far more grave and consequential.
In a comprehensive review conducted in mid-July, leading planetary scientists examined 4 primary explanations for the observed phenomena: extreme volcanism, core-driven thermal cycling, exotic magnetic processes, and astronomical measurement error.
Each hypothesis underwent rigorous evaluation against the accumulated observational data. All 4 explanations fell short, unable to account for the complete catalog of anomalies and their systematic relationships. The thermal stability couldn't result from volcanic activity. The pulse patterns didn't match any known magnetic phenomenon. The precision was too absolute for measurement error. As August approached, and the date for the LK-447 system's closest approach to Earth's orbital path drew nearer, the countdown accelerated. Every available instrument was positioned to observe, prepared to collect the data that might finally resolve the question that now consumed scientific inquiry worldwide. On June 14, 2025, the Atacama facility recorded LK-447b emitting thermal radiation 3 times more intense than all natural models predicted for a planet of its estimated size and stellar distance. Throughout subsequent weeks, coordinated research teams documented precisely structured atmospheric layers, a repeating electromagnetic signal pattern, and a sudden thermal surge coinciding with measurable orbital adjustment. These facts were confirmed by TESS satellite data, ground-based spectroscopy, and independent analysis from space agencies across multiple continents. Detailed atmospheric analysis revealed synthetic isotopic ratios and metallic signatures unknown in any natural planetary formation. Despite extensive peer review and intensive scientific debate, conventional explanations, including volcanism, magnetic processes, and geological activity, all failed to adequately account for the complete range of observed phenomena. The International Astronomical Union convened an unprecedented emergency panel to evaluate the data and discuss implications. As of late August 2025, the LK-447 system's closest approach to Earth's orbital path approaches rapidly, with observatories worldwide mobilizing maximum resources for direct observation. One thing has become abundantly clear. LK-447b challenges every established model of planetary formation and evolution. Its next passage through its orbital cycle will represent a decisive moment for planetary science and potentially for human understanding of our place within the cosmos.